Let's model up the 2-op cam and the fixture for this toe clamp. Welcome to another Fusion Friday. So a Patreon supporter sent this in to us as part of our Choose Your Own Adventure series and just asked, hey, how would you cut this, fixture it, cam it up, and so forth. So from a model or CAD standpoint, I want to just say great job. They've got the part in a component here, not doing your bodies and sketches in the assembly or parent. So that's really good. If you expand the arrow, you can see we've got the bodies and sketches. That all looks perfect. The last thing I'll mention is anytime you're importing a file into Fusion 360, I like to right-click on the file name and take a look. See how it says Do Not Capture Design History? That's the way I want it. If you toggle that, I'll click it here just to show you, it'll change to, well, actually, I don't want to do this. Basically, it's going to get rid of your timeline along the bottom, which is really bad, and I really wish Fusion would change the default for this, because I always want to capture my parametric CAD and extrusions and sketches and so forth. So cam, new setup. We are going to change our stock to fixed size box. I'll say 4 1/4, 1 inch, and let's say 1/2 inch. That's a pretty normal size to start with. And if we take a look, though, the way this has it defaulted is it's got the part suspended in the middle of our stock. And if I'm making a toe clamp like this, I'm going to be fine with the bottom being whatever the finish is from the mill, hot roll or cold roll. That's okay. So let's change it to machine all of the extra off the top. So see this model position? I'll change it to offset from bottom. And then it adds a value in here of offset. I'll just change it to 0. And you'll see now our Z0 is at the top of our stock, but it's going to machine it all the way down here in a second when we tell it to, at least, to right there. Perfect. Click OK. Actually, do I need anything else? No, we're good. Great. So how would I actually machine this? Well, what I would do is I would hold this part in a set of jaws. And so what we're going to do first is machine the top down and cut out this slot in this hole. So let's do that. 2D face. I'll pick, for me, it's tool 48, which is the shear hog. Where are you? 47 is the same thing. Here we go, 48 steel. And all I gotta do is click OK. Boom. It's gonna deck that top off. Drilling. Pick my hole. 266 hole. Tool. I'm not gonna worry about picking the exact right size drill for now. You guys can do that. You know how to do that. Under heights. Drill tip through bottom. That pokes the drill all the way through, which is important. I like to add a bit for good measure, and we'll do it on a peck. So instead of drilling rapid out, I'll change it to deep drilling full retract. Click OK. And let's then do an adaptive. There's actually a slot feature here. I don't use it. I'm just going to try the adaptive because that's what I'm used to the most to get this slot out. Change it to tool 30, which is for me a 1/4 inch end mill. And I'll click the bottom of that slot. Now, I bet you we're going to get an error. And if you ever get an error, I don't. It's because I changed my default. But see how my red helix there is really small? That's good. Most people won't get an error because on the last tab here, linking, the ramp diameter is too big. It would probably default to being like 0.2, and the tool can't ramp big enough to get in there. Now here's the thing, I don't want to ramp, period, because plunging stinks, ramping is slow. So back here when we did this drilled hole, let's also drill right here. Click OK. And so now what we can do is on this adaptive, right click, edit, the last tab linking, click, see this pre-drill positions? I click right here, it's going to know that we've got a hole pre-drilled there because I told it to, and it's just going to plunge straight down, which is perfect. Let's watch the sim of that. Sim, decks it off, drills, and you can spot that hole if you need to first, depending on the type of drill you're using. Drills that hole, plunges in, and my adaptive around there. Scrub forward here. Sweet. Let's check the settings on that adaptive. Passes. So perfect. No axial stock to leave and only 3 thou radial. I want this adaptive though to go a little bit deeper than the part just for good measure. So under heights, I'm going to say selected contours with a -10 thou offset. You take a look, it's going to push that toolpath just a hair below the part. To finish that up with a 2D contour, check this out. Right click, create derived, 2D milling, 2D contour, click OK. It pulls everything in, which is amazing. We're done. Setup here, sim, fast forward, perfect. So now that we've got that all done, we're going to move this into a fixture. Let me save my part here. So let's build that fixture real quick. Model, right click, new component, and call this fixture. And see how it's activated. That's good. R for rectangle, and I'll pick the bottom face of our toe clamp. It doesn't really matter for much where it is. D for dimension. We'll say 6 inches. 2, and I'll 1, just kind of get it eyeballed centered here. Isn't that important. Okay, so now if I hit E for extrude, this is cool. It's actually, we're still in our fixture component, but it sees the clamp stuff. So I'm going to extrude this, and I will also extrude that down. We'll say -0.5. Oops, +0.5. Cool. New body. Looks good. So now we need to add a pin location in here as well. I'm going to keep it away from this front because we got to do some work here. So I'll just put it somewhere here in the middle. So let's do this. P for project. I'm going to click on the top of my fixture. So that means we're working on a sketch plane that's the top of that fixture. And so it says here, select objects to project. I want to project this and this onto my my fixture. So click OK. Now, just to make this clear, I'm going to turn off the toe clamp so you don't see it anymore. So what we've got here is 2 lines. They're purple, which means they're linked back to the toe clamp, and that shows me what I need. So now I hit C for circle. I'm just going to sketch a small circle right about here. Now check this out. Tangent. I want this to be tangent to that, and I want this to be tangent to that. The distance doesn't really matter. I'll just make it a 2-inch known diameter, and E for extrude. I'll extrude this up. Now the truth is I would probably have that be a separate, oh, you know what? No, we're going to go the other way. We're going to have it be 2 screw clamps because I want it to clamp down, not just to locate. So let's undo that. E for extrude here, go down, boom. So those are 2 holes. I would drill and tap each one of those, probably 1/4-20. Yes, that hole is bigger right now. It's 354. Doesn't matter. In CAM, you can just pick your number 7 drill and then tap at 1/4-20. So I've got 2 1/4-20 holes there. If you take a look, they're pretty well aligned over the top there. Now let's do this for fun. Let's make sure a 1/4-20 screw will thread through here and still let us clean up this backside. McMaster. Let's see here. Oh, we'll do a socket cap screw. That'll be, well, socket head cap screw I know will fit. So let's do a hex head cap screw. Boom, boom. So 1/4 20, 1 inch. All I want here is the part number. Grade 9 is obviously overkill, but it'll look the same. So I highlight and Control C that part number. Now this is important. Activate your parent component. So now I'm going to go Insert, McMaster car component, paste that value. Basically the reason I use Chrome is it's a much better web browser than the one built into Fusion. I get to this screen, I can see here it says CAD, click product detail, scroll down, and I like to do step file, save. It's going to automatically import that screw in here. Click OK. Awesome. Let's put it in place. J for joint. Component 1 is going to be, well, actually, I like to change the motion type first. So this would technically be a revolute joint. So component 1, if I hover over this underside of the screw, I'm going to hold down the Control key, and that's going to let me pick the center dot right here. Component 2, same thing. I'm going to hover my mouse right here, hold Control. Now I can pick that coin right there. By picking, click OK. By picking those two faces, I pick the underside of the head and the top of this. I'm doing a joint that both aligns it concentrically, but also the right mating faces. So I don't want this to move around. So let's ground our fixture, and let's also ground our toe clamp. So those can't move now, and if you take a look, I can rotate that, and I can see regardless of where it tightens, I'm going to have room to run an end mill along this back edge here, oops, and clean that up. Awesome. Because we didn't, let's here, hop back into cam. We haven't done that yet. So this will be, I'll call it hold in vise jaws. Now we're going to have a new setup. Stock is going to be fixed size box. I'll do the same, 4.25 by 1 by point. Now this one will be, I'll say 0.5, even though it's, that doesn't look right. Oh yeah, there we go. It's not centered. So basically what I want to do is say, oh, so see how it's all screwed up? Okay, go back to the Setup tab. And see how it says 3 bodies in your model? I don't want 3 bodies. The only thing that should be is this guy. Perfect. Now we've already decked it off, so rather than worry about the exact height of this part, it doesn't really matter in this case. I'm just going to pick stock, offset from top, 0, and that's technically there's going to be some stock inside this fixture bar. It doesn't actually matter. So click OK. Now what I can do, we'll have a faster through here as well. We can do 3D adaptive clearing, and let's see here, geometry, pick stock contour. Actually, let's just take a look at what it looks like now. Heights, model bottom. You're going to see it doesn't go around our part like I want it to. And the reason is a couple things. One, actually I think the reason is because we don't have stock contours checked. We talked about this a lot actually in last week's Fusion Friday, but stock contours tells Fusion to pay attention to the stock that you've chosen in your setup. So now it's going to not just machine around the solid model, but it's going to take a look. Okay. I bet you it won't handle that because I've got to do tool outside boundary. Take a look at this pop-up window here, and you can see the difference between inside, the tool path or boundary on the center, and then outside. See if that works. Okay, I'm still not getting... let's see here. No axial stock to leave. Flat area detection is checked. add a little cushion here. Make sure it can, there we go. So now you can see it's going to go around and clean up all this stuff. It's not coming back here though. Wonder if I add more offset. Is that going to let it get back there? Yeah, okay. I honestly didn't, I knew to play with that, but I didn't know that that was going to be the answer. So if we click on operations, now we can simulate and we can actually just jump forward. So decks it off, drills, slots, starts to do the 3D adaptive, and then coming back there. And so take a look. We can also check for collision detection there. We're okay, but we may want to raise our clearance height there. In fact, that would probably be wise. Right here. So let's edit heights. Our clearance height should be, or it would be the retract height will be stock top plus 1/2 inch. Now we're going to clear that faster, no problem. So that's going to go through all that. Last thing we'll do, 3D parallel. I'll pick a ball end mill or bull nose. Let's see what we got here in the library. That ball works. And geometry. Well, let's edit the passes. The Stepovers, I'll say 0.1 just to show you what it looks like. Actually, let's just click OK. What do we get? So we get it going all over the place. I need to limit it to the face here. So edit. Geometry, this is absurd. It's easy once you figure it out, but change machining boundary to selection. So what is my selection? Well, unfortunately, you can't click on a face. I've got to click on a shape, but if I hover over right here, you can see it's picking the whole part. So that's what we have to start with. So click once, and you can see I've got this green line. I'm going to left click and hold down on that green line and let up. See how I got this new pop-up box? And if you're cursing at me right now, you have every right to do so, because this is something they need to do a better job of, and I think they are going to. So I want it to be a closed contour versus an open contour, so that's okay. Hover over this line, click it. So now I've got this enclosed shape. Perfect. To accept that, I've got to pick that green plus. Now I've limited my toolpath to this zone. Instead of tool center on boundary, I'm going to say you can go keep tool center on boundary, but you can go an extra 50 thou over all the sides. Click OK. That works, except it's a little bit too far spaced apart. So let's change it to say 0.03, and then check this out. I'll click OK first to show you. So that's a finer step down. That'll work, but there's a fun little quirk here you can do. Edit heights, change the direction to 45 degrees, and it's going to cut this on an angle, which is cool. But to get a cool little look, almost like fake knurling, we can also do add perpendicular passes, and now it's going to machine a 45 in both directions. It's really cool. It's really fun to play with. So now if we go back to operations, simulate, wrap it through it all, you can see, turn the toolpath off, there we go. Ooh, that's not good. Let me fix that little toe there. So why is that happening? Okay, so to debug this, or troubleshoot, I've got the parallel selected, simulate, turn off the stock, and now I'm just going to scrub through. So see, it's coming off. Shouldn't be coming off like that. I don't know. I think it only has to do with I'm not giving it enough offset. So let's change pairs here. Geometry to additional offset. Let's say it's 150. I bet you this will work now. Should go further down. It does. Operation, simulate, stock, fast forward. Boom. There we go. And the nice thing about this sort of a fixture is I would cut all of my first stops in the vise, and then I would put this fixture in. Oh, forgot a really important step actually. Your coordinate system is not as shown here. Your coordinate system, edit, is going to be a selected point right here, because you're going to reference off of this fixture, which is going to be held in a vise, and then every time you drop a new blank in, that screw and this pin will locate it. It should be repeatable enough. You could use a shoulder bolt back here if you needed it to be even super precise, and that's going to be your coordinate system to cut this part. So hope you guys learned something. Hope you guys enjoyed. If you did, appreciate the thumbs up and commenting. Otherwise, take care. See you next Friday.